Now, good evening. Now we'll do this problem that we left last week. Uh, Here we are given VA minus VB is equal to 6 volts. Now we are asked to find out what is VC minus VD. Okay. Now just assume this circuit is like this, and you have some circuit here. Then you have this current source and a resistance here. This is 2 amp. This is 1 ohm. This is 2 ohm. And you have another circuit here. Okay. Now we are told, yes, please. This is VA. This is VB. This is VD. And this is VC. Okay. Is this clear? This portion I am putting as a box. This portion I am putting it in a box. And this portion I am putting it in a box. Okay. Yes. Okay. Now I am. It's not. Yeah. So it is something, some network, some circuit. It is not an empty box. It's some circuit. Here also some circuit is. But we are not going into the detail of that. No, it is this. This is the circuit, right? See, this this is some circuit. Some current enters, some current leaves. Again, this is a circuit. Okay. In between, I have VA, I have VB. Here I have VC, VD, and here I have VC. I'm asked to find out what is VC minus VD. This is 1 ohm. Okay. This is 2 ohm. Now what I'm saying is the current that enters here will come out here. That only I wanted to explain. Current which enters will come out here. Whatever be this network, whatever enters this here will come out here. I wanted to tell you that. Not 2 ampere. See, what this current will come out here, not this here. Whatever enters here will enter here. What comes out of VA will enter here. This I want to make it clear. Okay. Whatever current enters here, then something involved will happen here. It will go here, and when it comes out, the same current will come out. That's what I want to say. Okay. Now, what is VA minus VB? What is this current? VA minus VB is 6 by 2 is 3 amp. So this current is 2 amp, 3 amp. This current is 3 amp. Okay. That means this current is also 3 amp. See, this current is going going somewhere and all in different directions going, and then combining and coming back here. No, whatever current goes, it will go somewhere. It will not get lost anywhere. It will again combine and come back with the same current. That is what I want to say. Okay, is it clear? Or I once again take another diagram. Here, let me do a nodal analysis here. Here, at this point, let me do a nodal analysis to make it clear. I- This current is 3 amp. Okay. Now, here, what you do is you do a nodal analysis. Let this be I1. Okay. Let this be I2 and let this be I3. Okay. So what is 3 amp? Or I can write minus 3 equal to minus 3 is the current entering this node is equal to I1 plus I2 plus I3. Agreed? Agreed? This I1 is coming here. This I2 is coming. This I2 is coming here. This is I3. So what is this? This is I2 plus I3. And what is this current? I1 plus I2 plus I3. What is I1 plus I2 plus I3? Minus 3. Okay. Okay. What is this current? I3. What is this current? I2. So what is this current? I2 plus I3. Voltage source is here. Voltage source is here. What is this? What is this current? See, this current is entering this voltage source. This current is entering this voltage source. That has to leave this voltage source. No, whatever current is coming here will not get blocked there. It has to flow. It will come here. Same current will come here. The voltage source, if any current I is coming, the same I will flow out of the voltage source also. It will not get blocked. So this is I2 plus I3. This is also I2 plus I3. And what is this current? This current is I1 plus I2 plus I3. Okay. Which is minus 3. So this is minus 3. This current at the point BC, this current is minus 3. Okay. That means whatever enters here comes out here. Enters here is minus 3. What is entering is minus 3. What is coming out is also minus 3. Okay. Okay. So now that's what I told you. Here, this is VA, this is VB, this is 2 ohm, VA minus VB is 6 volts, so this current is 3 amps. And here you have 1 ohm, here you have 2 amps. Now, what is the current source direction? Okay. Okay. And this current is 3 ohm, 3 amp. So, so that current, this current is 3 amp. These two together here. Okay. Now, this this current, this current is, what is this current? This current is equal to, no, 3. This 3 amps equal to what? This current plus this current. Okay. I am putting this current as Ix. I don't know the current. Ix. I put it as Ix. So what is tell me what it is. 3 amp is equal to Ix, huh? It's 1 Ix minus 2. 2 amp is okay. So Ix is how much? Ix is how much? 5 amps. So current that flows, this current is I 5 ampere. Okay. If 5 ampere flows like this, what will be the drop? Plus here, minus here. Okay. Voltage drop across the 1 ohm, the current flowing is 5 amp. So what will be the voltage drop? 5 volt. 5 volt will be this voltage drop. Okay. And minus will be here and plus will be here. We are asked to find out what is VC minus VD. What is VC minus? This is VC. This is VD. What is VC minus VD then? Minus 5. Okay. So the choice is, option is A minus 5. Understood? Clear? I want 1 minute. I'll again open this. So I'll again draw the circuit. Okay. You have a 2 ohm here. You have VA here. You have B here. Here you have 1 ohm. Here you have uh, 2 amp. Sorry, 2 amp is in this direction, and this 3 amp is flowing here. So 3 amp is flowing here means this current is also 3 amp. Okay. Is this clear? Hmm. Current. Hmm. Uh, see, this is VC, right? This is VC. Let's okay. When you want to find VC minus BD, this is VC. This is VC, right? This point is VC. Not showing it. Now, now, okay. Now this point is VC. What is this point? VC. Same point. This point is BD. What is this point? Ah, okay. So, so VC minus VD by 1 is equal to this current. Let me call this as IX. This current is IX. This current is IX. What is this current? This is IX. Okay. Now you have 3 amps entering. You have one IX entering. You have 2 amps entering. Okay. So all entering currents you add and equate it to 0. So 2 plus Ix plus 3 equal to 0. Agreed? All entering a point is 0. So Ix plus 5 is equal to 0. So Ix is equal to minus 5. What is Ix? Vc minus Vd by 1. So Vc minus Vd is equal to minus 5. Clear? Okay. Now we'll do this problem. In the circuit shown below, the current through the inductor. This current we'll have to find. Okay. Ah, that means it's on x-axis. 1 angle 0 means this point. Okay. So you need not, you can write it as 1, 1, 1. Okay. Now, uh, you do not know, uh, let's use this as reference. Let this 0. Okay. Let we do not, what is this voltage then? If this is 0, what is this voltage? Huh? There is a voltage source in between. No? Minus 1. This is minus. What is, what is this? Okay. Now this let us this no, this is not a voltage source, it's a current source. You don't know. So we'll put this as V1 and we'll put this as V2. Okay. Now in this you tell me the equation at V1. Hmm. 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 Equal to. Okay. Now you find V1, that's enough. Then you can find that this current. So let us find this one, V1. So I multiply by J. J V1 plus J plus V1 plus 1 minus J equal to 0. Okay. So plus J minus J. So V1 into 1 plus J equal to minus 1. So V1 equal to minus 1 by 1 plus J. And what is the inductor current? V1 plus 1 by J. This current is V1 plus 1 by J. This is 1, V1 plus 1 by J we will have to find out. So minus 1 by 1 plus minus 1 by 1 plus J plus 1 by J. Okay. So this is minus 1. This is minus 1 by 1 plus J. Whole thing divided by J. That means into J. So minus 1 get cancelled. This is J divided by 1 plus J into J. 1 by 1 plus J is the answer. It is option C. Okay. Now any doubt? Okay. Uh, you can also do it in the mesh analysis. Let us do it in mesh analysis. Okay. For mesh analysis, you will assume voltage current. In nodal analysis, you will assume voltage. In mesh analysis, you will assume current. Okay. Now we will take this mesh. This, let us assume this current I. This current is I. Okay. Then what is this current? This current is entering this point, right? Okay. Sum of current leaving that point. Then tell me what it is. Minus 1 plus I. Minus 1 plus I. Okay. The current and this current is the current entering this node. It is the sum of this current and this current. Current reaching a node, the sum of the all the currents leaving that node. That is minus 1 plus j plus I. I am assuming this as I. Now you do note that this current I know. What is this current? Minus 1 plus I. So what is this voltage? It is going in this direction. So drop will be plus here, minus here. Okay. This current is going like this. So the drop will be plus here, minus here. Now you take this from here. You start, go in this direction, go in this direction, go in this direction, go in this direction. One loop you take. So tell me, from here you start 1 into you should take plus or minus here. This is plus minus. Plus to minus means what you will take? Minus. Okay. Here plus to minus. So uh, J1 into hmm, I. Then here this is minus plus. Hmm. Then here minus 1. This and this will get cancelled. Minus will become 1 minus I. 1 minus I minus Ji is equal to 0. 1 equal to I plus Ji. So I into 1 plus 1. So I is 1 by 1 plus J. Okay. Understood. The average power delivered to an impedance 4 minus 3J by a current 5 cos 100 pi t plus 100 is. What is power? V into I. Okay. Now let me just give you some explanation and then do this problem. Okay. If when it is if V is 5 cos omega t, suppose B is 5 cos omega t, suppose, and I is some 2 cos omega t minus some angle. Okay. Huh? Then what is the power? Instantaneous power. 5 cos omega t into 2 cos minus 5. So this is 10 cos omega t minus 5. So every time it keeps, I've assumed, I'm just assuming, suppose voltage is this and current is this, I'm deriving what is the, no, this is called instantaneous power. Means every time it changes. Okay. So in AC circuit, every time power changes, so I'll find out what is the average power. What is the average power? How will you find average power? You integrate it over a period of time and divide it by T. Okay. So this, if you integrate this, you will, this cost term will go, and what you will get is, if you integrate 10 by t, if you integrate this, you can write this as cos A cos B is actually cos of A plus B, A minus B plus cos of A plus B by 2. So cos 2 omega t. If I add cos 2 omega t minus phi, and if I subtract cos omega t minus pi, that is cos phi. Okay, by 2. Cos A minus B plus cos A plus B, cos A plus B plus cos A minus B by 2. So this, if I integrate with respect to dt, this term cos 2 omega t, if I integrate it over a period of time, it is actually going to be 0. Okay, so only this term will be there. So you get, and if you integrate it, so you will get 10 by 2t integral cos phi. Cos phi is a constant, cos phi, and integrated to the dt. If you integrate, you will get t. From t to 0, if you put, it is into t. No, sin cos phi is constant. Cos phi has no, if you integrate, it will not become sine, because it's a constant, it's a number, it's a simple number. There is no function of t. So this t and t will get cancelled. We will get phi cos phi. Okay, you are getting phi cos phi. What is phi cos phi? It is actually VRMS into IRMS cos phi. So this is the equation for power, average power. VRMS, IRMS cos phi. Okay. What is VRMS? VM by root 2. What is IRMS? IM by root 2. Cos phi. So what is Vm by root 2? Vm is what? Phi. Phi by root 2 into Im is what? 2. 2 by root 2 cos phi. So 2 and 2 will get cancelled. It is phi cos phi. So by example, I have proved that it is VRMS, IRMS cos phi. Okay. I assumed V is equal to phi cos omega t and I is equal to cos omega t minus phi. If there's a phase difference, then it is VRMS, IRMS cos phi. Okay. Now, here you are asked to find what is the average power. So, what is IM? Here current is given, IM is given. IM is equal to phi. Okay. This is I. IM is phi. Okay. What is, how will you find VM? I into Z is V. I into Z is equal to V. Okay. What is Z? Z is 4 minus 3j. The magnitude of 4 minus 3j is actually 5. Root of 4 square plus 3 squared is 5. Okay. Vm is Im into mod Z. So Im is how much? What is Im? 5. 5 into 5, 25. Vm is 25. Okay. Okay. So what is it? Formula VRMS, IRMS, cos phi. Okay. The cos phi is because of this term. This only will create this cos phi. So Z is what? Z is 4 minus 3j. Okay. So this can be written as, this is 4 minus 3j is something like this. Okay. And this, because of this, there will be an angle caused by this. So this is actually mod Z cos phi plus mod Z sin phi. J mod Z sin phi. Okay. This is actually, so cos phi is actually 4 by 5. 4 by 5 is cos phi. Okay. 4, this is phi, this angle is phi, 4 by 5 is cos phi. Okay. So what is what is VM? VM is 25. 25 by root 2 into 5 by root 2 into 4 by 5. Okay. 25 by root 2 into 5 by root 2 into 4 by 5. So root 2 into root 2 is 2. So this will get cancelled with 4. You get 2. 5 and 5 will get cancelled. 25 into 2 is 50 watts is the answer. Because there is a shortage of time, I'm just rushing. So answer is 50. Another way of doing it is IRMS squared times real part of impedance 4. What is IRMS squared? 5 by root 2 the whole square into 4. So 5 by root 2 squared is 25 by 2 into 4, that is again 50. Okay. Okay then, it is getting close. Thank you. God bless you.